3 ships every single day. That was the American answer in 1943. Not a speech, not a slogan. Ships. 3 completed Liberty ships a day, rolling out of American yards while German U-boats tried to win a war with arithmetic. The German command had made a cold calculation. Sink merchant tonnage faster than the Allies could replace it, break the supply line, starve the Atlantic crossing, force Britain and then the Allied war machine to run out of hulls. It looked like a numbers game. Then America changed the numbers. By the end, the United States had completed 2,710 Liberty ships between 1941 and 1945, the largest class of ships ever built, not destroyers, not battleships, cargo ships, plain, boxy, hard-working cargo ships, the kind of ship an enemy planner could underestimate, until the production reports arrived, until the losses no longer matched the replacements, until the U-boat war became a factory problem, and America was very, very good at factory problems. The German U-boat command was fighting what was called a tonnage war. That was the idea. Do not think first about individual ships. Think in totals, gross register tons, monthly sinkings, replacement rates, capacity. If the U-boats could sink enough merchant shipping, month after month, the Allied lifeline would shrink. That was the wager. Before the United States fully entered the war, the U-boat arm needed to sink about 300,000 gross register tons per month to overload Britain's ability to replace losses. That was the figure. That was the bar. But here is the first crack in the enemy's calculation. In the first 27 months of the war, the Germans reached that 300,000-ton monthly target only 4 times. Only 4. And then the problem got worse for them. After December 1941, American merchant shipping and American shipyards entered the equation in full force. The target effectively rose. Now the U-boats needed something closer to 700,000 gross register tons per month. 700,000 every month. That was no longer just a naval problem. That was a race against Detroit logic, Pittsburgh steel, California yards, Baltimore yards, Gulf Coast yards, and workers all over the country feeding parts into a national assembly line. The Germans reached the 700,000-ton mark in only 1 month. November 1942, 1 month. After May 1943, the average sinkings fell to less than 1/10 of that figure. Less than 1/10. That is the moment the arithmetic failed, because the Allied yards did not merely replace ships. They began to overwhelm the losses. The U-boats could still sink ships. They could still disrupt routes. They could still force convoys to work hard for every crossing. But by mid-1943, the central German bet was collapsing. No matter how many ships the U-boats sank, they could no longer outpace the production of new ships. That sentence is the heart of the story. No matter how many ships the U-boats sank, they could no longer outpace the production of new ships. And the symbol of that reversal was the Liberty ship. The Liberty ship was not glamorous. It was not designed to impress admirals at a parade. It was designed to carry cargo across oceans during an emergency. Its formal designation was EC-2SC-1. That sounds like a filing cabinet label, but it tells the story. EC meant emergency cargo. 2 meant a ship in the 400 to 450 foot length range. S meant steam engine. C1 was the project design. It was based on a British cargo ship design from the late 19th century, then modified in the United States for wartime production. That part matters. The Liberty ship was not a miracle because it was futuristic. It was a miracle because it was buildable. America did not need the most elegant cargo ship in the world. America needed a ship that could be built again and again and again by workers who had never built ships before, in yards that were learning as they went, with parts arriving from thousands of factories across the country. The enemy had built a strategy around sinking steel. America built a system for replacing steel, and the system was the weapon. The first Liberty ship was the SS Patrick Henry. It was launched on September 27, 1941, at the Bethlehem Fairfield Yard in Baltimore. That date became Liberty Fleet Day. Across several yards, the first 14 emergency ships were launched that same day. President Franklin, the 500th. Roosevelt connected the new class to Patrick Henry's famous line from 1775, "Give me liberty or give me death." Roosevelt said this new class would bring liberty to Europe, and the name stuck, Liberty ships. It was a perfect name for an ugly job. The ships were sometimes called ugly ducklings in the press. They were not sleek, they were not pretty, they were slab-sided, practical, and built for work, but that was exactly the point. The German command was not beaten by beauty, it was beaten by output. It was beaten by a nation that looked at an Atlantic crisis and asked the most American question imaginable: how do we make this faster? The old way of building ships depended heavily on riveting. Riveting took skill, it took time, it took teams, it took a lot of labor, and in earlier shipbuilding, riveting could account for about 1/3 of labor costs, 1/3. So the Liberty program shifted to electric welding. That was one of the decisive engineering choices. Welding reduced the need for highly specialized riveting crews. It made it possible to bring in new workers, train them, and put them into production, including women, including people who had never worked in shipbuilding before. The war had pulled many men into military service. American industry had to expand anyway, so the yards and factories brought in new hands. Welding opened the door. It did more than save labor. A welded hull was smoother than a riveted one, less surface interruption, less drag, less friction, but the big advantage was speed. The U-boat war was a stopwatch, so the American yards took time out of the ship. They stripped it away wherever they could. They did not wait for a full hull to rise from the keel piece by piece in the old style. They turned shipbuilding into a modular process. Deckhouses, double bottoms, stern frames, bow units, sections built away from the final building way, pieces fabricated outside the yard, parts made in factories all across the country, then moved in, then welded together. More than 30,000 components could go into one Liberty ship, 30,000. And instead of every piece being made at one crowded waterfront site, the nation itself became the yard. That is the part the German calculation could not absorb. A U-boat could attack a ship at sea. It could not torpedo the organization chart that built the next ship. It could not sink the welding school. It could not stop the rail cars hauling prefabricated sections. It could not stop thousands of factories from feeding steel, machinery, and assemblies into the system. This was logistics as a form of combat power. Quiet, relentless, overwhelming. Henry J. Kaiser became one of the most famous names in that story. His yards, and yards using his methods, produced a huge share of the Liberty output. Kaiser brought a builder's mind to ship production, break the job down, standardize it, pre-build as much as possible, move work off the critical path, use assembly line thinking, use management as a weapon. The results were stunning. Historically, ship construction could average around 230 days. Kaiser yards drove that down to around 45 days. At the peak, less than 3 weeks. Not as a one-time stunt, as an industrial curve, as learning, as practice, as a system getting better with every hull. By 1943, Kaiser lines were producing on the order of 140 Liberty ships per month, 140 in a month. Across the whole Liberty program, the average came to about 3 ships every 2 days, and in 1943, 3 completed ships per day, 3 per day. Imagine that number arriving on an enemy staff table. Not a forecast, not an aspiration, a production fact. The German U-boat command had wanted a monthly tonnage contest. America made it a daily launch schedule, and the cost was also part of the victory. A Liberty ship cost about $2 million at the time, roughly $46 million in 2025 dollars. For an ocean-going cargo ship built in wartime, that was not a luxury item. That was industrial ammunition. Every Liberty ship was a floating warehouse, a replaceable link in the chain. A hull built not to be precious, but to be present. That is a different kind of power. Navies often talk about the biggest ship, the fastest ship, the most heavily armed ship, but the Battle of the Atlantic demanded another question. How many ships can you keep in service? How many can you build? How fast can you replace them? How much cargo can still move when the enemy believes he has cut the line? The Liberty ship answered, again and again and again. Then came the symbolic record, the SS Robert E. Peary. If the Liberty ship program was the machine, the Robert E. Peary was the thunderclap. Its keel was laid on November 8, 1942, at 12:01 in the morning. Permanente Metals Corporation, Yard No. 2, Richmond, California, a Kaiser yard. 4 days later, on November 12, 1942, at 3:27 in the afternoon, the ship was launched. 4 days, 15 hours, 29 minutes, from keel laying to launch. Then came delivery. 7 days, 14 hours, 32 minutes, from keel to delivery. The Robert E. Peary was assembled from roughly 250,000 individual pieces weighing about 14 million pounds. Think about that. 250,000 pieces, 14 million pounds, moved, positioned, joined, inspected, driven through a schedule that looked impossible until American workers did it. But here is the honest part. That record was not normal production time. It was a propaganda effort. It was part of a competition between yards. The shipyard prepared for it. It prefabricated as much as possible. It positioned sections in advance. Some pre-assembled sections weighed 250 tons, with engines already in place. The point was not that every Liberty ship took 4 days. The point was that the system had become so organized, so modular, and so confident that it could stage a demonstration like that at all. It was a message. To Americans it said, "We can do this." To the enemy it said, "Your arithmetic is obsolete." That same month, November 1942, was the only month when the Germans reached the new 700,000-ton target. The timing is almost too perfect. At sea, the U-boats hit their one great monthly number. On land, in California, a cargo ship was being assembled at record speed to prove that America could build faster than ships could be sunk. That was the strategic collision. Torpedo versus template, periscope versus production line, tonnage war versus American scale, and scale won. The first escalation in this story is the enemy's assumption. The German U-boat strategy assumed the war could be reduced to losses and replacements. If sinkings stayed high enough, the Allies would fall behind. This was not irrational. Shipping was vital. Britain depended on imports. War production depended on material movement. Armies needed supplies. Air forces needed fuel and parts. The ocean routes mattered. So the U-boats attacked the numbers. But the United States turned the same numbers into a manufacturing challenge. The answer was not one heroic ship. It was a class of 2,710. The answer was not one perfect yard. It was 18 American shipyards. The answer was not one master craftsman. It was a workforce expanded by welding, training, and simplified production methods. That is where the enemy's calculation began to slip. They were counting ships destroyed. America was counting production cycles improved. The second escalation is the factory network. A Liberty ship did not begin only at the waterfront. It began in factories, in steel, in components, in standard plans, in assemblies made elsewhere and moved into place. More than 30,000 components per ship, thousands of factories feeding the program. That meant the waterfront yard was not doing everything from scratch. It was assembling a national effort. This is why the Liberty ship is more than a ship. It is a map of American industrial power. A welded seam in California could be the final joining point for work that started far inland. A deck house could arrive ready to place. A bow unit could be fabricated before the hull around it was complete. Work could happen in parallel. That is the secret. Parallel work. The old way forces one step to wait for another. The new way asks, what can happen at the same time? That question crushed the calendar. It took construction time from hundreds of days to weeks. It let new yards learn fast. It let managers measure progress. It let workers repeat tasks and get better. It turned emergency shipbuilding into a production science. The German U-boat arm had to find targets in the Atlantic. American industry only had to find the next bottleneck and eliminate it. That is a quiet kind of genius, not flashy, not romantic, but devastating to an enemy that had gambled on scarcity. Because scarcity was exactly what America refused to accept. Steel was organized, labor was trained, factories were linked, yards were expanded, and the ships kept coming. The third escalation is the turning point. March 1943 brought heavy Allied shipping losses, more than 500,000 tons. That was a serious figure, a dangerous figure. The tonnage war was still real, the Atlantic was still contested. But then came May 1943. In that month, Allied ship construction surpassed destruction. From that point forward, the strategic meaning changed. The U-boats could sink ships, but they could not sink them fast enough. They could impose costs, but they could not reverse the production curve. They could threaten lanes, but they could not win the arithmetic. After May 1943, average sinkings dropped to less than 1/10 of the 700,000-ton target. The German command's central wager had failed, and it failed in the most humiliating way for a tonnage war. The tonnage went the other direction. The enemy had tried to make the Atlantic a graveyard of Allied capacity. America made it a proving ground of Allied replacement power. Every Liberty ship that slid down the ways was a message in steel. You can sink ships, we can build more. You can force convoys to fight. We can keep the cargo moving. You can measure tonnage. So can we, and our numbers are rising. There were problems too, real ones. The Liberty ships were built fast, and the engineering had to learn under wartime pressure. About 1,500 cases of brittle fracture occurred in Liberty ship hulls. This was not simply a matter of bad welding. The key issue was metallurgical. In the cold of the North Atlantic, steel could become more brittle at low temperatures. The ductile to brittle transition mattered. A welded hull was continuous, and that meant cracks could propagate in ways they might not in a riveted hull. The engineer Constance Tipper helped demonstrate the cause. That matters because it shows the system was not magic. It was engineering, and engineering learns. Specifications improved. Steel reinforcement was added. The causes were understood, and the vast majority of Liberty ships served without failing. That is another American strength in this story. Not perfection, correction. Find the fault, study it, fix it, keep building. The Liberty ship program was not a fairy tale where every decision was flawless. It was a real industrial campaign, with pressure, with limits, with mistakes, with learning. And still, the output was overwhelming. The enemy had counted on the Allies being unable to replace what was lost. But American production did not stand still long enough to be counted accurately. It accelerated. Early shipbuilding experience became later shipbuilding speed. Workers became skilled. Yards became efficient. Design became process. Process became rhythm. Rhythm became volume. Volume became strategic power, and that power moved through the Atlantic in convoys. The Liberty ships carried the material that kept Allied operations alive. They were not glamorous, but they were indispensable. Cargo is the bloodstream of a modern war. Food, fuel, vehicles, parts, equipment, industrial supply. Everything that must arrive before armies can move and air forces can fly. The U-boat command understood that. That is why they targeted shipping in the first place. But they underestimated the other side of the equation. They saw ships as targets. America saw ships as products. That difference changed the war at sea. A target disappears when it is hit. A product returns when the line keeps running, and the Liberty Line kept running. There is something deeply American about the whole story. Not because the ships were pretty, they were not. Not because they were perfect, they were not. But because they were practical, standardized, mass-produced, improved, and delivered. They were the hardware version of refusing to quit. The enemy tried to make the Allies feel shortage. America answered with abundance. The enemy tried to turn the ocean into a ledger of loss. America answered with a ledger of launches. The enemy tried to calculate collapse. America recalculated capacity, and the result was visible at the yards. A keel laid, a section lifted, a weld completed, a hull launched, a ship delivered, then another, then another, then another. At the beginning of the war, the German tonnage strategy aimed at a vulnerable point. Merchant shipping mattered. The U-boats did not need to defeat a battleship fleet to create a crisis. They needed to reduce transport capacity. That was the logic. But after the United States entered the industrial equation, the U-boat force faced a moving target. The monthly requirement rose toward 700,000 gross register tons. That is an enormous burden for any submarine campaign. And they reached it only once. Only November 1942. After that, the curve bent away from them. By 1943, the Liberty ship program was running at a scale that made the original German calculation look small. 3 ships per day. A whole class of ships, completed by the thousands. 18 yards, modular construction, electric welding. A workforce widened by necessity and training. Women joining industrial production as welding made new entry possible. Kaiser-style management driving schedules down from hundreds of days to weeks. This is the part that should make every American viewer sit a little taller. The victory was not only won by those at the front, it was also won by people holding torches in shipyards, by planners moving assemblies around a schedule, by engineers studying cracks in cold steel, by railroad logistics moving components to the coast, by managers timing work so the next section arrived when the yard was ready, by workers who built something they might never sail on, by a country that understood that freedom also needs freight capacity. Liberty needed ships, so America built them. The SS Patrick Henry gave the class its name. The Robert E. Peary gave the program its legend. But the real hero was the whole production system, a system so large that no single U-boat could see it, a system so distributed that no patrol line could stop it, a system so repetitive that each success made the next one faster. That is what astonished the enemy. Not one ship. The rate, the rhythm, the replacement power. The German command had tried to win by making losses unbearable, but the United States made replacement unstoppable, and once that happened, the tonnage war lost its teeth. A U-boat commander could still report a sinking, but somewhere back in America, another hull was nearing completion. Maybe 2, maybe 3 that day. That is the strategic nightmare for any enemy. To strike and see the other side grow stronger anyway. To count destruction and discover the opponent is counting production. To believe the war is arithmetic and then meet a nation that can change the math. By mid-1943, the answer was clear. The U-boats could not sink ships faster than America, and the Allies could build them. The wager had failed. The Atlantic lifeline held, and the Liberty ships kept coming. Plain ships, urgent ships, welded ships, American ships, built not to impress the enemy, built to bury his calculation.